live.
Yes.
Hey everybody, welcome back. It's really great to have you all here. We just had two fantastic talks. And Richard, if you're here, sorry for butchering your name earlier. My team informed me it's pronounced Richard, best guy ever. We love him, and Nas is fired. I love that name. Sounds a little Russian. Anyway, so we'll hear a little bit from Christian and Philip on the outlook and a little recap. So, what has happened in this foundation that you announced last year? What's going on there?
Yeah, right. Probably I can start, right?
Yeah, let's do it.
Yeah, last year was a pretty busy year. We had a lot of going on. Once we had the idea of actually founding the foundation, there was a lot of legwork to do, and basically the idea, right, that we came up about a year ago is that we need some kind of umbrella corporation to cover the needs that we have and all the movements that are going in the open source firmware ecosystem around. And we thought about that we need something that we can actually accelerate the open source firmware adoption industry-wide, and make it a little bit more solid project, right? So not some couple of hackers.
Let's say
right?
independent from also our company and Nine Elements, because we are just a single company, and if we somehow decide on some point we don't do firmware anymore, or whatever happens here, or someone dies, then there's no there's hopefully this is not happening in the future, but who knows what happens, and better to have some backup plan, right? And probably have multiple companies on board instead of being a single company there. That's quite important.
Yeah. So we came around with the idea of founding the foundation, having that umbrella corporation for the OSF projects, and that we can do like promotion, funding, conferences, hackathons, and so on and so forth.
Case studies are important.
Case studies are also important. Yeah. And the question now is, where are we standing now, right? We did the announcement a year ago. Like what did we actually do 1 year, right?
Yeah.
And yeah, it's pretty nice. So we do have the foundation right now. So there is a foundation called Open Source Firmware Foundation. It does nothing right now, but we have it. And it has been officially founded 19th of April. So that's that you can mark it red in your calendars, basically. It's a 501c3 tax-exempt status non-corporate corporation.
Yeah,
which is easy to remember. And we wrote down the article of incorporations and signed them off. We have the bylaws ready by now, and we do have the membership ready.
Yeah.
The membership contract ready, which is probably also pretty important. And we actually have a nice propose in there, I think, right? So the overall meter idea, like what the foundation should do, that we came up with, is actually, and I'm basically quoting from the articles of incorporation, is to research and educate corporations and individuals alike about open source firmware through sharing intellectual resources, infrastructure, service, events, and training. Right?
Oh, that's
so
a long
it's
sentence.
A catchy sentence, but that's exactly the idea.
Yeah, that's correct.
And of course, we have the website ready, up and running. Check it out. It's opensourcefirmware.foundation. Also, that is not a catchy address, so we got osfw.foundation. We already had a couple of information on that, so feel free to check it out. And there's also contact there, so if you want to drop us an email, feel free on that. Yeah. And what's ongoing right now? So I think that's probably the more interesting thing, right? What are we working on right now? We are in the process of onboarding the founding members. So we're talking to companies, to people, if they want to join the foundation. We applied for trademark.
That's just right. So we applied for 2 trademarks, right?
Yeah, we did, yeah.
Yeah. So one is the Open Source Firmware Foundation trademark, right? That makes sense. And we also applied for open source firmware. So either we can get the trademark. If we can get it, then probably you can claim it and protect it from misuse, or we can claim it, which is also a good outcome because then no one can claim it, which is nice.
Better have it than needed, right? So
Yeah,
I think that's the idea.
that's correct. Yeah.
But yeah. Okay, cool. And actually, and the most complicated thing that we're working on right now is the bank
Account
account.
in the US.
I mean, it's just horrible. There's so many stuff you have to go through, so many things you have to work out, and it's even worse because we are not U.S. people, like U.S. citizens, right? So
Yeah.
that makes things more complicated. However, we got some help on that, and we're moving forward. So I hope we can finish that off pretty soon. Yeah, and that's the rough where are we standing right now.
Thanks for that. We also have guests with us today for a little questionnaire. So we have Frederick here from Mulvad VPN and Brian from Oxide. Hi. And Ron. They said the Ron and only a legend in our ecosystem and Google. So welcome, everybody. It's really nice to have you here. There were some questions in the community, and first one goes to Frederick. So open source firmware is all about transparency. So how does it impact your business, basically?
Okay, so we intend to make our VPN infrastructure transparent and auditable to our customers. And in general, I think you can say that code that runs close to the metal or early in the boot chain has more power over the platform, which can be leveraged to protect it or to compromise it. And such security critical code simply has to be open source. Closed source firmware is a liability to us. So that's the impact that open source firmware versus closed source firmware has on us.
Great, thanks for that. Christian, how about you? Has open source firmware been like the core thing of our business here, like from the very beginning? Like, where do we stand on that?
Yeah. Actually, yes, right. So, I mean, Philip, probably you can tell more about that. But like when we started, we did start it with open source firmware straight away. So that was actually the first contract that we had, like the first work that we did here. I think when we thought about the name, like what we're actually doing here, we thought we do more cybersecurity. That didn't work out. We only do firmware like 90% of the time. That is our core business is on open source firmware, and it's around open source firmware and firmware security, right? So I think that's also where the connection of cybersecurity actually comes from. OSF like has a huge impact obviously on our business because we are only working in that space. Like everything that we do is upstream first. We open source as much as we possibly can. Sometimes, of course, there are NDAs in place, which makes it hard. But we're trying to move forward on these kind of things. And of course, like it's like a living system, right? So open source firmware has an impact on our business, where we're going and what we can actually do, what we're capable of support. But we can also change open source firmware and the ecosystem a little bit, right? So I think it's going back and forth in terms of in a good way, right, and not fighting. And it's a living organism. So that's pretty cool. Yeah?
That's nice. Brian, so you founded Oxide as a computer company. How does a computer company utilize open source firmware then?
Well, I mean, yeah, clearly for the machine, the software that runs the closest to the machine is the software that we've called firmware. And it's very important to us at every layer of the stack. And what we have seen is that unfortunately, with this layer, with firmware being proprietary, we have seen all of the problems that we know that proprietary software causes. And, I feel like along with my fellow panelists who are roughly of the same vintage, we come from a pre-open source era. We lived through an era of proprietary compilers and proprietary databases, and it sucked. There's just nothing good to be said about it. It just sucked. And the quality was low. It had real adverse impacts to what people wanted to go do. And the development of open source is, along with the internet and think some other kind of key innovations, but open source is one of the most important technological advances in our lifetimes, right up there with the internet. And we could not build the public cloud on proprietary software. It could not have been built. You could not have built, the economics would not have allowed Google and AWS and Microsoft and so on to build their software on strictly proprietary software. Those companies needed open source software. And now we are finally, so we know that proprietary software sucks, that it's the wrong model, that it's good for software companies for the short term, but bad for customers in the long term. And at Oxide, we've seen that. We've seen that when we were trying to build our own machines and our own clouds. We saw all of the perils of proprietary firmware, and part of the thesis of the company was that customers are sick of it, that people want to be able to buy a machine that is reliable and robust and testable and transparent. And open source firmware very much advances all of those things. It is deeply in the customer's best interest for this to be open. I think one of the things that's been a little bit surprising is the degree to which customers see that themselves. That is to say, people who are purchasing compute are technically savvy. They also see this. And they, I think vendors have kind of taken them for chumps for 2 generations. And the customers are not idiots. They're being treated like idiots, but they're not idiots. And they're frustrated. And what we knew is that there was, we believed, room in the market to be an open company, but one with a very clear monetization model. We've got God's own open source model. We sell hardware. That's what we sell. And I think that all of these companies that, and I think it's not just around open firmware, we want to see this revolution spread to EDA, to the FPGA, and that's coming, right? That's happening. It's not happening as quickly as we'd like, of course. And I think that, your intro to Ron, intro for Ron was totally appropriate. I think Ron is very much the godfather of open source firmware, and God bless him for staying patient for however long. I mean, Ron, it's been a long time that you've
longer.
22.
You can see the
years.
frustration in his face, right?
Oh yeah, it's like I know what Ron's thinking. Ron's thinking too damn long. It's been too damn long. But honestly, and I think this is something that I've learned through my career, is that these revolutions take a very, very long time to effect, and it takes just a lot of effort for a lot of people, and often it is not the same person that is able. Some people just get exhausted and put the torch down, and they need someone else to pick the torch up. We are lucky to have someone in Ron who has held the torch for so long, and a new generation of technologists that's coming in and helping us pick up the torch and advancing it forward. But we are, because the other thing to know about open source and the reason to have confidence in the future, open source took over software because it is a one-way trip. When once a domain has a viable open source alternative, that domain will never be proprietary again. You cannot delete open source. You can't put it back in the bottle. And it takes a long goddamn time, but once you get there, you've arrived. We move forward as a ratchet, and it's happened to operating systems a long time ago. It happened to databases. It happened to compilers a long time ago. All of those things. I mean, actually, honestly, you look at like the compilers, open source compilers, which we don't even, a proprietary compiler is like not even a thing anymore. That was actually a very important precondition for open firmware. We've got that now. That is deeply ubiquitous, and open firmware is happening. We are trying to do it in a very ambitious way, in that what we are trying to do at Oxide is not just have open firmware on our service processor and on our root of trust. That's relatively easy because we're developing that de novo. We just announced that this morning, and we viewed OSFC. We're huge OSFC fans, so viewed OSFC as a great occasion to open source that. It's been fun to see that and get a lot of traction and a lot of excitement. But that's kind of the easy stuff because that's the stuff we're running from scratch. The stuff that is much, much harder is the software that is, it is so deeply proprietary that it has become interwoven with the proprietary hardware. And to the point where hardware vendors don't even understand the dependency that they have. And that's the stuff that we are currently teasing out. Again, Ron's been huge in that. You've got our commitment. You, the broader community, have a commitment from Oxide. We're going to open source everything that we've got because we believe that open source firmware it is a critical extension of this most important revolution that we've been enjoying in terms of open source. Ron, how's that for an intro for you? I'll pass it to Ron.
It's fine. Or well, I noticed Nicholas here. I didn't know, so I'll let you pick the order of who goes next.
Well, I'll just make a short comment to what Brian said. I think it's really for me it's really exciting to I mean, open source is I think it's Red Hat who says this. Open source is a powerful innovation engine, and it's going to be interesting to see what firmware vendors inevitably decide to align their businesses with this innovation engine, and which will sort of resist. And another thing is like how I'm quite surprised how many of them still haven't realized that they are. I mean, they haven't seem to have realized some of the opportunities that lie before them, and nor have some of them realized that they are or shortly will be in the security business, and whether they want to or not, and what that means. So it's going to be exciting to see, like, because I have my hypothesis on what the future, where the future will inevitably lead, just like Brian said. Yeah, but we'll see. Some of them are probably not gonna go so well for them. So it's interesting.
Yeah, I think that's actually a safe bet. So Brian's right. Like, I'm old. So and I've watched. The thing I've been able to watch is the companies that didn't want to go open, and the companies that resisted Linux. I'll hurt Brian's feelings and talk about Sun. But the thing that you tend to see, which I've always found very interesting, it's not a gradual decline. They roll along like this. They refuse to be open. They refuse to be open. They hit the cliff. And I think the x86 guys in particular need to start worrying because they're not getting it. And I'll give you a number. In the year 2001, we had server processors from AMD and Intel. 100%. If you look at the ROM part, 100% of the firmware in that ROM was derived from GPL code, namely Linux files. If we go and look today, we'd find maybe 5%. If we're lucky, maybe we're with Linux boot and uroot, at places like Google and ByteDance, we're getting closer to 40%, but still 60% of the bytes in a ROM are derived from closed source proprietary goo. And we've had a long running conversation Brian's been involved in with AMD. I've had a 20-year conversation with Intel about this because they were that open and they made a decision to go closed. And what you're seeing, big announcement today, Amazon's having RE Invent. I don't know why all the Amazon people aren't here, but they're not, haha. But they're announcing Graviton 3. And if you really look at where the openness is, it's not in the x86 world, notwithstanding the excellent efforts of Oxide, they're gonna break a lot of it open, but it's still a fight. But basically, you're either open or you're roadkill. And maybe it takes long, maybe it happens quickly, but I think the x86 folks better start looking hard at what they're doing, because as Frederick points out, it's about security. The biggest problem I've had dealing with Intel and AMD is all the people who say, "Oh, you're just religious. You're a religious person about." And you're a this phrase Stalmanite, all these bullshit words you get from various people in these companies. But what it boils down to is, no, I care about security, right? I've worked in classified environments where this kind of thing really mattered. And running, 16 megabytes of code that I can't verify at all, especially knowing how full of bugs and security holes it is, it's not really a practical approach going forward. And I just can't figure out why the x86 vendors haven't kind of figured this out yet, but they haven't. But I do think if they don't, then OSFC in 10 years won't have any x86 track because that'll be a dead architecture. And so that's my feeling. So, they need to get it together. So that's my take. But they haven't been going in the right direction. One little last data point. Up through 2014, AMD, we were totally open source on their processors, 100%. And they decided in 2014 to, lock us out. What's interesting, in the Orbit work on AMD and the Corbett work on AMD, where we've been trying to open it up again, AMD's having a really hard time pulling that off. And part of the reason is they don't actually seem to know where a lot of the firmware comes from on their chips and who owns it. So they walked into a closed box, and it's pretty hard to walk out again.
So I'm going to
and maybe not just because I mean, there are many reasons, of course, and one is that they're just so large, these organizations. It's not gonna, if they on some strategic level realize that, oh crap, the reason people want open source security solutions is not for some political religious reason. It's just good engineering. Security, I mean, well-designed security technology is all about essence. There is no accidental complexity, or there's a minimum of it. The easier it is to understand, the more well it's documented, the easier it is to inspect and reason about it, the more likely you have designed something that's actually secure. And so it's just good engineering to insist on, documentation. I
will give you a concept of the level of effort involved, and I'll back out a little in terms of naming names. You can probably guess them, but there was an EU government that offered to boycott one of the major x86 vendors. The whole nation, the government of the nation, was going to stop buying x86 chips from this one vendor unless they gave access to a developer who was doing a core boot port for a laptop, right? But it is ridiculous. It is ridiculous that it came to the point of a government having to bring down the hammer that hard. But that's how silly it is in the x86 world. And we all know it's not that way in the ARM world quite as much.
So I'm going to be marginally more charitable to the x86 vendors, which puts me already in an uncomfortable position because it's not. But I think that part of the challenge and part of the difference between 2014 and now is that these chips themselves are computers. They are way more complicated than they were even 10 years ago. And we have got, and this, by the way, is not unique to x86. And so I on the one hand, I'll defend x86 a little bit. On the other hand, don't lionize ARM. And there are plenty of proprietary bits, especially ARM is about to be purchased by the most proprietary silicon vendor on the planet.
Yeah.
And so the problem is actually at once deeper in that we have got very complicated computers now on the chip. These things all run different firmware blobs that we cannot see. We have to push for openness among those blobs. We do not have source code to AMD's PSP, for example. That should be open source. We do not have source code to Intel's management engine. That should be open source. But we also don't have source code. If you look at any ARM vendor or RISC-V vendor, you also have proprietary blobs there that we don't have source code towards. They may be small.
We have too many blobs across the platforms, right? So Intel ACMs and many other things. It should be actually much more transparency. To be honest, open source firmware doesn't create security by design, but it's gain transparency, which is foundational baseline for basically create security. And to be honest, proprietary vendors always arguing for obscurity, and we see some of the hardware vendors actually even remove the names of some function protocols. They really believe it will be stop reverse engineers. And to be honest, it's not. We just reporting with encoded name these vulnerabilities, and it's not stop us reverse engineer the logic, right?
But I think there's a I mean I completely agree that open source itself doesn't, you know, if you have two code bases, one is proprietary, one is open source, which one has less bugs? No idea. But I think one of the key things for me is yet again open source as an innovation engine and the feedback loop that it creates. If you have documented solutions, inevitably you're going to have a tighter feedback loop, and bad decisions, bad engineering decisions, bad designs, they die in sunlight. But if it's proprietary, then, you know, but ultimately, if you go back to hardware vendors, it's not going to matter, because hardware is way easier to design today than it was, you know, 10 years ago. It's going to be even easier 5 years from now, which is super exciting, because ultimately, you know, someone will seize the opportunities that are just lurking down there close to the metal. And I think this is super exciting, because the wonderful thing about computers is they do exactly what we tell them to do. Our ability to instruct them is an entirely different matter, but ultimately, if we can get firmware and platform security features right, secure systems are possible, and or more secure systems are possible, and that's really exciting, I think.
So one theme that both Alex and Frederick and Ron raised, but one thing that I certainly think that we as a community need to emphasize is the need for these parts to be fully documented. And that is actually the first step, is to get full documentation.
Yeah.
And there, and you know, I know someone in the channel said that, you know, RISC-V is a step in the right direction. RISC-V is a step in the right direction. That is true. RISC-V is also is not on a 5 nanometer process. It's not actually making a server part. And what I see and what I'm worried about in RISC-V and the RISC-V vendors is some of the same early moves that we saw out of x86 that led to proprietary firmware deep in the stack. So we really need to push for these parts to be fully and completely documented. I mean, right now with x86, we can't get full documentation even under NDA. That is entirely unacceptable.
I got to jump on you real quick because we're running out of time, and I'm getting tired of this RISC-V thing. RISC-V is a step in one way, a right direction in one way only. It's an unlicensed instruction set. That is the only thing they do that's any way different. I've been working with the RISC-V for 8 years. I did the first Coreboot port. They have really screwed the pooch in a lot of ways on RISC-V. Let me mention one or two. They actually implemented hardware in the spec from RISC-V International that enables SMM. Okay, dumb, right? They have implemented hardware in the spec that can lock down firmware in ways that you can't get rid of it. Dumb, right? The most recent thing they did in the last few years is they standardized on, guess what? UEFI as the desired firmware model for RISC-V. Dumb, all right? RISC-V is not open source. A lot of people like to say it's open source. Incorrect. It is not open source. RISC-V has all the problems of all the other processors with proprietary DDR controllers, proprietary GPIO controllers, all kinds of proprietary hardware. RISC-V solves no problems at the moment that we need solved in most implementations. And RISC-V International, in fact, is pushing standards in the wrong direction for everything we care about at this conference. So do not push RISC-V as some magical solution to our problems. And in fact, it is actually a problem in itself. It's going the wrong direction. And RISC-V International is a large part of the mistakes they've made. So,
Amen.
Yeah.
Yep, totally agreed. And I think the thing that's most compelling about RISC-V is the ability for us to drop soft cores into soft logic. That is really interesting.
Yeah.
And just what Ron said, the free availability of that instruction set, the fact that it's not licensed, very interesting. Lots of other things about it, deeply alarming. And ARM too, right? We need to push together arm in arm on these vendors, document your parts. And if you can document your parts This is a very capable community. We got a lot of very clever folks. If your parts are documented, we can get it working. And if your parts are not documented, we can't. There are things that are simply not feasible without documentation because these parts are so complicated and so opaque.
Brian, I think you raise a very important point. Without documentation, open source firmware will not going to happen, right? So basically, I think many proprietary vendors open source the firmware stop because they don't have documentation. They don't want to document proprietary technologies, and that's a problem. And actually, I think that's a major caveat to get in the place we want to be.
I think that's right, and I think that when each of us is talking to a vendor, it is easier to get a vendor to document their interfaces than to open up their own software. So if you've got a proprietary boot block that you're getting after, first let's get the interfaces that proprietary boot block is using. Let's get those completely documented, because we have found that is at least there's more viability there. That's an important way station, because sometimes if we ask for too much at once, we get nothing. The one thing I will also say in the x86 vendor's defense is, at an executive level, they get Ron's dictum that they are open or roadkill. That's actually understood at an executive level. That was not true at Intel a decade ago. I think that is true.
Yeah.
That is more true now, which is reason for optimism, but there's a long way to go.
I've seen firsthand how the strategic direction is direct, and you have too, Brian, right? But strategic direction dictated by VPs and CEOs gets frustrated by business unit lawyers, and I'll be blunt. No, I won't. Middle management meatballs. I'll be blunt. Middle management meatballs who see who see their power base threatened because something will be opened up, and
which ultimately constitutes a business opportunity for those that see the opportunities and are willing to act on them.
One thing I should mention, because a security researcher at ETH Zurich told me the story. He said if you go to some countries where you might have opened a barn and found a line producing illicit drugs, you would find all that equipment is gone. And he had to explain the terms to me, but he said you'd find a decap line and e-beam machines, so they have the ability to strip off layers of silicon, almost not one atomic layer at a time, but very, very, very finely strip off the layers of the chips and do e-beam machine reading of everything about that chip. There is a gigantic amount of money in organized crime. And if anyone thinks they're hiding something from bad people, they're nuts, right? They're not. And if I really, really, really wanted, well, two things. Anybody who really, really wants to follow the source code to UEFI, go to the dark web, okay? And secondly, occasionally, before I really, really brought the hammer down and said we don't want to hear about this anymore, in the first few years of Linux BIOS, people every once in a while would come and say, hey, I just found all the source for the MI BIOS, do you want it? And we just say, good God, get out of here. We don't want to hear about this. Just don't ever bring this up again. And in fact, one of the people who offered it a few months later said, I'm about to go to jail. I didn't think I could go to jail for stealing this code, but I guess I can. The point being that all this stuff is out there. They're not if they think they're keeping secrets, they're not. It's just that, we're very nice people in our community and we don't do that sort of thing, right? So,
yeah, I think there's a lot of opportunity to educate people, bring awareness to also to the managers through case studies and so on. I think this is let's say long-term journey, but we can make it. So I mean, we have the opportunity now to develop partly open source firmware, right? Probably for some platforms it's completely open source, but we're going to the right direction. And I think, as you said, as long as the competition is going on now in the x86 market and also other processor markets joining in, it's getting more and more complicated for proprietary SOC vendors to be successful in that market. So I think that's a good thing. So in general. But anyway, we have, I guess, more questions left. Or not.
All right. I
Have
talked much.
more questions?
Yeah, probably we have to speed up a little bit because we already took so long. So probably you have to cut out some questions and directly jump to the work streams. Work stream.
I mean, I think we've addressed the what do we think about the future, for instance. That's pretty much what we discussed.
Yeah, I think that then we are basically done with the question anyways. And next is, so Alex Matrosov is already there. You can see him. He already joined. So he's basically responsible for the first open source firmware foundation work stream.
Yeah, but let's
you want to
first explain like what is a work stream?
Okay,
right?
you can do it, right? So
No,
should
go
do
ahead,
it? Okay.
Go ahead. If
Okay.
you jump right in. Go ahead.
So an open source firmware foundation workstream is basically like a workstream where it's a group of people who want to solve a specific problem or want to work on a specific topic. It's similar to the OCP projects, probably, or the Linux Foundation project you probably know. And so it's a little bit different for the open source firmware foundation in terms of policies and restrictions. So the work streams itself are completely, let's say, self-contained, and they have the power themselves to work on stuff. So we don't want to intercept in those work streams, at least not hardly. So that means the work stream itself can do what they want as long as they work on the specific topic. And at the moment, the foundation is there, but we want to get work streams onboarded. So we decided not long ago, I guess, Alex, probably we met each other in June or July 1st, I'm not sure. And then we started work on the firmware security workstream, which was basically the first workstream. And you probably want to give a short introduction into the firmware security workstream, or should I do it?
I can do it. So I think, first of all, it's very important work for the industry. We try to connect different companies, different people, and work together on the problems which exist. As example, in the talk we covered today with Kai Michalis and Richard Hughes about like the problems where we don't have a right classification for vulnerabilities. Basically, CVSS scoring in many cases misleading. And we need to more precise classification will be help companies to understand the impact, and this impact will be more connected to their internal threat modeling to actually get patched, because what we're currently facing, vulnerabilities which is 1 day for years became 0 days for many companies in reality. And as example, like USB-RT issue, which we mentioned just recently, a few days ago, we found the same issues exist on some enterprise vendors, and the issue exactly the same, which has been disclosed 5 years ago, which is ridiculous and scary, right? So, and of course, like if it will be open source firmware, it will be more transparency, and definitely it will be cached before, but it will be cached in the main repo. We need to make this patched in the field. That is another problem. And all these topics we try to cover on the work stream. And we need the help from the community, and hopefully more people will be applied in our call to action to join the work stream and actually help the industry to solve such of the problems. And actually, I'm very happy to hear from Brian about Oxide and transparency they making on their computers. So that's amazing, and hopefully it will be a good example for the industry how the open source and transparency on the hardware can actually gain much more security level.
Perfect workstream introduction, I would say.
Yeah, nothing to add.
Yeah, nothing to that. Basically, we also do specification and guidelines, I guess, right? So, but that's probably coming later on. First, classification of vulnerabilities are the most important part. Yeah. But do we have another work stream?
Yes, we do. So actually, there's another work stream forming up right now, which mostly Andrea and Tobias from Meta are involved, right? So the one that's also taking care of contest right now, and it's about firmware testing, right? So I think testing is a very important part of software development, obviously, and we need more testing in the open source firmware world. And I think we need to engage that, how we do that. Every company or a lot of companies do things on their own. There's no common thing how to do it. We don't, I don't know, pull all the results together at a centralized place so that everyone knows what's going on.
It also starts with the test, right? So
Yeah.
do we have for example, do we have a specification which all tests you do? I mean, it's not always different, right? It's every time it's the same test site, or let's say 90% of the tests are similar. And so you need to have an open specification for tests,
Right.
and you need also to have probably an implementation of tests which can be used already with the existing open source tooling, which makes it great for doing hardware quality assurance, right? So, and that's where we want to help out.
Yeah, right. I think like what's reality right now is like a couple of OEMs have like a couple of Excel sheets that they go manually through, right, and they take things off. I mean, that's reality, and we have to move forward on these kind of things, right? We have to, as you said, like what should be tested and in what way, right? And have a standardized way on doing things, so that we can all agree that we are speaking the same language here. We did these kind of tests so that we know, okay, what kind of assurance do we have on that software part? And that is very important for me. I personally are very involved in that topic, so probably also involved in that work stream somehow. However, Andrea and Tobias voted for leading that, which makes me very happy. And I hope people get involved in that too and contribute to that.
Yeah. By the way, we will soon on the Open Source Firmware Foundation homepage some updates, so you can see the work streams, you can participate, and you can directly see where the meetings happens and the meeting protocols and everything. So stay tuned for that. So we're working on that at the moment. Should be ready by mid of December probably.
Yeah.
And
Hey, I'm afraid we're running out of time, and I just want to thank 9 Elements because we have been talking about a foundation for 20 years. And everybody talked about it. 9 Elements has made it real, and it is a gigantic step forward. Really, really, really great work. So thank you.
Yes, thank you.
no problem.
Thanks.
Thank you guys to make it happen.
I hope you're all gonna join the foundation. Is that a yes, Ron? Yes. Looks like
What's
it.
it?
I said I hope you're all gonna join the foundation. It was really nice having you here. I loved the lively discussion, lots of firm stands, and we're gonna move on now, and we're gonna have a talk from Cliff. He's gonna tell us about on hubris and humility, developing an OS for robustness in Rust. So thanks for being here today, and happy to have the next talk.
That's the Oxide talk, right? We are
Thank you. Bye.
super thrilled, right? That is exciting. All right. Thanks, everyone.
Thanks. Bye-bye.